All right, today we're going to go on a bit of a quest for the perfect digital tunnel. It's a journey through the history of a technology that a lot of us use every single day, but maybe don't fully get. I'm talking, of course, about the VPN. So, let's dive in. It's really the fundamental question of digital privacy, isn't it? In a world where absolutely everything is connected, how do you carve out a private space for yourself? This exact problem is what sparked the whole idea of the VPN in the first place. So, what even is a VPN? Well, think of the internet as this massive public highway system. A VPN basically builds you a private, armored tunnel that runs right through that public highway. All your data travels inside it, totally shielded from anyone trying to peek in. It's your own personal, encrypted express lane. But you have to ask, why did we even need to build these tunnels to begin with? Well, to answer that, we've got to jump in the time machine and go way back to the Wild West days of the early internet. See, in the very beginning, the internet was basically built on the honor system. Data was sent completely out in the open, unencrypted. It was like sending a postcard that anyone along its route could just pick up and read. Now, imagine you're a big company and you need your employees to connect to your private network from home. Yet, this was a massive security nightmare. The solution they came up with was this brilliantly simple idea called tunneling. It works like this. First, your data gets put into a package. Then, that package gets placed inside a second, totally encrypted, locked package for its trip across the internet. And once it arrives safe and sound at its destination, it's unwrapped. Simple, secure, and honestly revolutionary. So, with that concept in place, the race was on to build the first truly reliable tunnels. Let's meet some of the original pioneers of VPN technology. Our story really kicks off in the mid-90s. Microsoft gets the ball rolling with one of the very first VPN protocols called PPTP. But tech moves fast, right? And very quickly, we saw an evolution to something called LTTP, which then found a crucial partner for security in IPsec. Now, PPTP was kind of the first hero on the scene. Its superpower was simplicity. It was just super easy to set up and get going. But it had a fatal flaw. Its encryption methods, which everyone thought were strong at the time, were eventually found to be full of holes. I mean, today using PPTP is basically like locking your front door with a paperclip. Okay, so next up was L2TP. It was great at building the tunnel part, but here's the catch. It provided zero encryption, none. It built a perfect tunnel but totally forgot to put any armor on it. So it had to hire a bodyguard called IPsec to handle all the security. That created the L2TP/IPsec combo that was a standard for many, many years. But as the internet grew up, so did our needs. Those older protocols were often kind of clunky and complicated to use. The world was just ready for a new generation of heroes, one that was really built for the modern web. And this slide really nails the shift. The old way, with stuff like IPsec, meant you had to install special software on every single computer. It was a huge headache. The new way, SSL VPNs, was a complete game changer. It used the exact same security tech that already protected websites, that little padlock icon on your browser, to create a VPN connection, a lot of the time without any extra software at all. And riding that wave was OpenVPN. It pretty quickly became the absolute gold standard for well over a decade. So why was it so popular? Well, for one, it was open source, so anybody could check the code for flaws. It was incredibly secure, super flexible, and had this huge active community behind it. For a very long time, OpenVPN was the answer to the quest. But of course, technology never stands still. The internet got way faster, we all moved to mobile devices, and the quest for that perfect tunnel demanded something leaner, meaner, and built for the 21st century. And that's when WireGuard entered the scene. Now, to really get WireGuard, you have to understand its core philosophy, something called cryptographic minimalism. The whole idea is that complexity is the enemy of security. So by using only the most modern, efficient code and just throwing out all the old baggage, you create a much smaller attack surface. That just means fewer places for bugs and security holes to hide. And wow, this chart just visualizes that philosophy perfectly. Just look at that difference. OpenVPN, which is a fantastic protocol, is around 400,000 lines of code. WireGuard, it's just 4,000. That is 100 times smaller. It's so small that a single security expert can actually read through the entire thing in an afternoon. So what does all that simplicity get you as a user? Well, for starters, blazing fast speeds. The lean code just runs incredibly fast. It also uses the latest and greatest cryptography by default, and its tiny footprint is absolutely perfect for our phones and other mobile devices.
Okay, so we've met the pioneers, the old standards, and the new kid on the block. Let's put them all side by side and check the official scorecard on our quest for the perfect tunnel.
This table really does tell the whole story. You can see the entire evolution laid out right here. PPTP, obsolete. L2TP/IPsec is really just for older legacy systems. OpenVPN is still that versatile, all-purpose standard with very, very strong security. But if you look at the top performer for both security and speed, well, WireGuard is the clear winner for any modern, high-performance needs. So our quest has brought us to this amazing place with technologies like WireGuard, but the story doesn't end here. The internet, as always, keeps changing, and there are always new challenges popping up on the horizon. You see, the big challenge today is that networks themselves are just getting smarter. They can use these advanced techniques to inspect traffic and figure out that you're using a VPN, even if they can't see what you're doing inside the tunnel. This has kicked off a constant cat-and-mouse game between detection and obfuscation. And this has led some people to ask if maybe we need to think beyond the tunnel entirely. There's an emerging model called Zero Trust Network Access, or ZTNA. Instead of giving you a tunnel to the whole network, it follows one simple rule: never trust, always verify. It only grants access to the one specific app you need and nothing else. This could very well be the next chapter in our security story. Which brings us to our final question. This quest for a private, secure connection online has taken us from simple, broken protocols all the way to incredibly lean, fast, and secure tunnels. But as our digital world gets more and more complex every day, will the idea of the private tunnel, which has served us so well for so long, still be enough to protect us? That's the question we'll all be answering in the years to come. Thanks for joining me on this one.